I finished coughing before the beep went off, so it's not actually in the video, but me talking about it now is in the video, which is way more entertaining. So today we're still in 4.2. The beginning part of 4.2, where you guys didn't have any assignments at all, was just us going over that unit circle, right? And we're going to get into that a little bit later. But right now, what we're going to talk about is the trigonometric functions. Trigonometric functions. And you guys know some of them from probably geometry. You guys did sine, cosine, and tangent. And today we're going to go over those in a different context, as well as add in their inverses, which is like cosecant, secant, and cotangent. And how they relate to the number line, and specifically how they relate to the unit circle. But the definition of the trigonometric functions are based on their point values, right? As far as when we graph them and on the unit circle. And so it's really helpful to know certain things about them. So I'm actually going to write out the definition. I hope it's legible, but it is. We are going to let t, some t, be a real number, any real number. That's not super legible. I wanted it to be. My one thing about this Zeitboard thing is that I can't just turn the pen over and erase with it like I can on the other. Let it be a real number. So it could be any real number, right? We don't know what it is. And we are going to let X and Y be a point on a unit circle. Which is kind of what X and Y is for us always, right? It's like a point on a plane. Corresponding to t. Ultimately, what we're saying is that if we have sine of t, it is equal to the y value, right? When we're talking about x values and y values, the sine of t would be equal to the y value. Cosine of t would be equal to whatever that x value is on that point. And then the tangent of t would be equal to sine over cosine, which is y over x. Now, the trigonometric functions, the three primary trigonometric functions are sine, cosine, and tangent. But each of those have an inverse function. Sine has an inverse function that is called cosecant, and we put it like that. We shorten it with CSC. And cosecant of t would just be equal to 1 over y. The inverse of cosine is secant. And I always got confused with this because it felt to me like cosecant should be with cosine, but it's not. So keep that in mind. Cosecant is with sine, secant is with cosine, but it is equal to 1 over x. And then cotangent of t, you can just flip and it would be x over y. So these are important pieces of information because if you're asked to evaluate any of these, you kind of know, like if you know where the point is, if you know a point value of something, you can find the exact value of sine over t or cosine, I mean, sine of t, cosine of t, tangent t. And what you're going to be asked to do in your homework, and what we're going to go over here today, is you'll get questions that say evaluate all of all 6 trig functions at such and such. So it may be like pi over 6 or pi over 4. And those would be pertaining to the unit circle itself. It might be, though, it'll give you values. Like the first ones that you'll have in terms of your homework will give you like specific coordinate values. So if you have, say, if you are given, for example, let's change colors. If you're given an x value and a y value, say I have 2 and 5 as a point, right? And you are given this point, asked to evaluate all 6 trig functions based on this point, right? What you would do is you go, okay, well, sine of t in this circumstance would be whatever y is, right? And this is our x and this is our y. And we go, well, sine of t is just 5, right? And we would go, okay, cosine of t in this circumstance, well, that's our x value, so that would be 2. And tangent of t would be y over x, so that would be 5 over 2. Does that make some sense? So not too complex. When we did cosecant of t, that's 1 over y. Well, that's just 1/5. Secant of t will be 1 over x, which is 1/2. And cotangent, we just flip it, and we would have 2 over 5. Here's the thing. Your numbers are going to be more complicated than this, but the process isn't going to be more complicated than this. Okay? Because sometimes you're going to have a fraction over a fraction, or you're going to have a square root within it, and you're going to have to rationalize the denominator of the square root, which happens a lot. Because if you remember when we were talking about the unit circle, like we had like a lot of radical 2 over 2 or radical 3 over 2 stuff, and you can't leave that alone if they're piled on top of each other. The one you'll have to work hardest with in this is tangent and cotangent, because you've got one value over another value. So if you have a fraction over a fraction, but we are going to deal with all of that. But it will really help if when we're doing these sample problems, if I bring in a picture of a unit circle. And I'm really hoping I have one saved in here and I don't have to go find one and bring it in. But no, I don't. Let me grab a picture of a unit circle really quick. I mean, I could write one really quick, but it'd be so much easier not to. So let me import this unit circle I just grabbed an image of. So we are going to move this over here and we'll move it around with us as we need it. But what you can see on this is each piece on here has a value, right? It has an XY value. Um, so if I am asked to evaluate all 6 trig functions, and when you guys have your homework, some of them won't ask you for all 6 trig functions. It'll ask you specifically for like sine, cosine, and tangent, but some of them will ask you to find the value of all 6 trig functions, and it'll ask you for the exact value based on the location. So if you are asked to evaluate all 6 trig functions at, let's go with a t equals pi over 6, that means we want to find all 6 trig functions based on this xy value where pi over 6 is, right? And so the points that we would be using here would be radical 3 over 2 and 1/2 for my xy values. Does that make some sense? So I will put this picture of the unit circle into Google Classroom so that you guys have access to it when you're doing this. But you're just going to look for, well, where's pi over 6 on this unit circle, and what are those xy values there? And then we can do it. We could go, okay, well, sine of pi over 6, well, that's going to equal y, right? Which is just 1/2. Cosine of pi over 6, that's going to equal our x value, which is radical 3 over 2. Here's where it starts getting crazy, right, though? We've got tangent of pi over 6, and that equals 1/2 over radical 3 over 2. And we can't leave it like that. So we would go 1/2 times 2 over radical 3, right? We multiply times the reciprocal, and these cancel and we get 1 over radical 3. But guess what? Can't leave a radical in the denominator. So we would have to multiply this times radical 3 over radical 3, and we get rad 3 over 3. This would be our solution. So this is why I said it's like, see our lights go up. And so you're going to have to simplify these expressions, right? But the process itself is still the same. You know what points you're working with. Next, we would do cosecant. And cosecant of pi over 6, well, that's just 1 over sine. So it would be 1 over 1/2, right? And 1 over 1/2 is technically like saying 1 times 2 over 1, which is just 2. Next, we would have secant of pi over 6, right? Which we know is 1 over radical 3 over 2. And again, we have to rationalize that denominator now. And so we're going to go 1 times 2 over rad 3, and that gives us 2 over radical 3, but we can't leave it there, so we have to go radical 3 over radical 3, and we get 2 radical 3 over 3. And then the last one would be cotangent, right? Cotangent of pi over 6 equals, we had 1/2 over rad 3 over 2 for tangent. It's the opposite here. It would be radical 3 over 2 over 1/2, which does make it easier because that would be radical 3 over 2 times 2. These would cancel, and we would just be left with radical 3. So when you think about this, you go, oh, okay, well, it's just the x, it's just the y. And it really is just those things, but it's a lot of simplifying as well. Does that make some sense? So I will do like another example of that because that's a lot of information. But for the most part, that is really all you're doing with this assignment is you're going to be given a set of values or an area where to find those set of values, right? And then you're going to use those values to figure out the exact values of each trig function. I'm trying to move this unit circle, but it does not want to move. I'm wondering if I have to, I guess I have to, well, what I'll do on the next one is I'll just scroll back up after we write it down. But part B, so if I'm going to do another problem with this, I want to do it at B is t equals 5 pi over 4. So I have to figure out, well, what is the xy value at 5 pi over 4? And so I'm going to scroll back up to my unit circle, and I'm going to go, well, where the heck is 5 pi over 4? All right, well, it's right here. It's negative radical 2. If you see here, it's negative radical 2 over 2 and negative radical 2 over 2. Both values are the same, right? They're both negative, clearly because they're in quadrant 3, which is always all negative. And so we're going to come back down here and we'll just write that point so that we don't have to keep looking at it, but it's also an easy one to remember because we've got negative rad 2 over 2 and negative radical 2 over 2. And so when we're finding sine and cosine, super easy, right? Because we just sine of, dang it. So sine of 5 pi over 4 is just, this is our x, this is our y, but they're both the same, right? So we know it's just negative radical 2 over 2. And cosine of 5 pi over 4 is just negative radical 2 over 2. But now it's going to get a little bit more complicated for us because we're going to have to do some work on it, right? When we look at this tangent of 5 pi over 4, we're left with negative radical 2 over 2 over negative radical 2 over 2. That's going to make this positive for one, because a negative times a negative is a positive. But here I'm going to have negative radical 2 over 2 times the reciprocal, which is negative 2 over rad 2, which just equals 1, right? If I multiplied this together, it would be 2 rad 2 over 2 rad 2, and anything over itself is just 1. If we looked at it in terms of cosecant of 5 pi over 4, right? This is where it gets more complicated because we know that sine is negative radical 2 over 2. But if you remember, cosecant is 1 over sine. So it's 1 over negative rad 2 over 2. And then we have to deal with that fraction, right? That would be 1 times negative 2 over radical 2. And then we just have to, which is going to give us negative 2 over radical 2. And then we have to get rid of that denominator, right? Because it's a square. So we're just going to multiply it times radical 2 over radical 2. And that will give us negative 2 radical 2 over 2. which actually can be reduced, right? Because 2 over 2, it just gives us negative radical 2 as a solution. So you're going to have to play with these a bit. The cool thing about negative radical 2 over 2 is it means that secant is going to have the exact same solution. So I don't have to do the math again because x and y are the same, right? And so I know that this would also be negative radical 2. Why? Because the math is going to be the same, right? It's still going to be 1 over negative radical 2 over 2 because x and y are the same. And so I'm going to save myself all the work of having done that. And cotangent, think about this. Cotangent of 5 pi over 4. Well, we just did that, right? If this is x over y, it's also y over x. And so we know that this would just also be equal to 1 without doing any of the math on it. Right? But if you don't, that means you have to write this again. But then maybe you might recognize, oh, I just did this over here. And I know it's going to have the same solution. The only other thing I want to show you, because all of the problems are going to be like this, right? It's going to be like either find the 6 trig functions or find 3 specific trig functions. And you're going to go through this process every time just with different numbers. Sometimes it'll just give you the point right off the bat. And other times it will give you like t equals something and you have to go figure out what the point is at, you know, that on the unit circle. What I want you to pay attention to is sometimes you will be given your value in, say you were asked to do it when, see, when t equals something negative, like negative pi over 3, and you want to know what that value is. Think about this. That means we're going the opposite way around the unit circle, right? So if you look at your unit circle and we want to find negative pi over 3, well, pi over 3 is at 60 degrees here. It's going to be the same thing, right? Down here, but it's going in this direction. So if you go up 1 quadrant here to get pi over 3, it's the same thing down here. So you would have these values right here. So it's still 1/2 and radical 3 over 2. It's just that the radical 3 over 2 is now negative, right? So keep that in mind when you are doing that. And all you have to do is kind of remember, well, what quadrant am I going to be in if I go in the negative direction? So you know if it's positive or negative and which parts, right? So in this case, the point that you would be dealing with would be 1/2 and negative radical 3 over 2. And I'm not going to go solve those numbers out again because I feel like I kind of did it already and it gives you a pretty good idea of how these work. But all of your problems are going to be based on this. Did I assign you a lot of them? Kinda. It's going to be tedious. But I want it kind of ingrained in you, which is why I kind of assigned you so many of them. Can you cheat on this? Probably. But, you know, it's so much better if you learn it. Because the unit circle is such a cool thing to deal with, and it's kind of a cool thing to get an understanding of. But for the most part, that is all I have for you guys today. Yeah, so that is it. Unless you have any questions, I think it's pretty straightforward. It's just tedious. Um, but if you guys have any questions, I'll stick around to answer them. But otherwise, I'm going to stop the video.